Hello scientists, in this video we are going to be talking about thermal energy. By the end of this video you should be able to define thermal energy, name its two factors, and describe how thermal energy moves within a system. Let's get started. What is thermal energy? Well, thermal energy is the total amount of kinetic energy in all the particles that make up a substance. Now, if you remember, kinetic energy is the energy of movement. Now, you might notice this mug here, and it might be sitting on the table, and nobody's touching it, nobody's drinking from it, it's just sitting there. So how could it be moving? Well, all substances are made up of these tiny particles called atoms, and these atoms are always moving. So even a substance that seems to be just sitting there and not moving, inside whatever atoms make it up, they are moving. This movement translates into thermal energy. Let's go ahead and fill in the blanks. Thermal energy is the total amount of kinetic energy in all the particles that make up a substance. There are two factors of thermal energy. They are mass and temperature. Before we consider these two factors, I want for you to keep in mind the definition of thermal energy. It is the total amount of kinetic energy of a substance. Kinetic energy is the energy of movement. It's also important to understand the idea of mass. Mass is a measurement of the amount of matter, and all matter is made up of particles. So if I were to ask you which has more thermal energy, a lake or the water in a bathtub, what would you say? Well, if you consider the factor of mass, the lake, if you could take all the water out of the lake and find the mass, it would have a whole lot more mass than the amount of water that would be in a bathtub. So in this case, the lake has more thermal energy because it has more particles or more atoms that are moving. And so therefore the lake has more thermal energy than the water that's in the bathtub. Now, something that might seem a little more familiar to you is if you were to look at let's say a mug of hot chocolate and a glass of ice cold water, and I asked you which one has more thermal energy, well, you probably would say that the mug of hot chocolate. But why is it? Well, in this case, it is the factor of temperature. So because the hot chocolate has a higher temperature than the ice cold water, then the hot chocolate has more thermal energy because its particles are moving much more quickly than the particles in the ice cold water. So what is the difference between temperature and heat? Temperature is a measurement of the kinetic energy of the molecules in a substance. If temperature is a measurement, then we need a tool to be able to measure. So the measurement tool that we use is a thermometer. This measures the movement of the particles of matter. Let's go ahead and fill this in now. Temperature is a measurement of the kinetic energy of the molecules in a substance. So what is heat? Heat is really the movement of thermal energy from one substance to another. And this thermal energy always transfers from the warmer substance to the cooler substance. Heat is kind of more of a general term that we use, where measurement is more specific because we can actually give it a number. But if we were comparing two things, we would say, oh, well, this substance is warmer than this substance. And really, that's due to the speed of the molecules. Something that is warmer has molecules that are moving more quickly. So we'll give them 2 speed marks. And then if something is cooler, we might give them, we'll say they're not moving as fast. So we'll just give them 1 speed mark. So temperature is a measurement, and heat is really the movement of thermal energy. There are 3 methods that thermal energy is able to transfer through a system. They are convection, conduction, and radiation. We will learn more about these throughout the lesson. Let's take a moment to summarize what we've learned so far. Thermal energy is the total amount of kinetic energy of a substance. Temperature is the measurement of the kinetic energy of a substance, and heat is the movement of thermal energy between substances that are different temperatures. Let's take a moment to fill that in. Scientists have developed a rule based on the patterns they saw when studying thermal energy. It says that thermal energy will always transfer from the warmer substance to the colder substance. Let's do a couple practice examples. I want for you to circle the object with more thermal energy. Remember that the 2 factors of thermal energy are mass and temperature. So when you are looking at 2 things that are similar, that have different masses, the one that is a greater mass will have more thermal energy. So therefore, the larger elephant will have more thermal energy than the smaller elephant. If you are looking at things with, say, similar in size, but are at 2 different temperatures, then the thing that is warmer, let's say the hot chocolate, will have more thermal energy. Now it's your turn to try. Look on the opposite side of the page, and I want for you to circle the objects in each example that have more thermal energy. All right, that's the end of the information. I want for you to go back, review your notes, and answer these 4 wrap-up questions. I wrote you a little note down at the bottom. It says thermal energy, temperature, and heat are related but different. And you have to know the differences. That is the key to understanding this lesson. Okay, good luck.